Welcome to our online chemistry class. Our topic is solutions. Let us discuss part 1 of this topic. So, in this topic we will discuss first introduction, then types of solution, then capacity of solution to dissolve solute. Next one is solubility, then vapor pressure of solutions of liquids in liquids. Next important concept of this topic is colligative properties of non-electrolyte solutions. In that, different colligative properties that you have to learn: lowering of vapor pressure, then elevation in boiling point, depression in freezing point, and osmotic pressure. Then lastly we will discuss colligative properties of electrolytes. Then let us discuss the introductory part of this topic. So in this topic, first we must know what is the meaning of mixture. Okay, so let us discuss the definition of mixture. Mixture is a combination of two or more substances, and these substances may be elements or compounds. So all are familiar with that bhel is the best example of our mixture. Or if we add your sand in iron and if you mix them, then it is a mixture. Okay, so if you mix two things or more than two things, then we get a mixture. But what is the important thing is that they does not react themselves, and we can separate the individual substances by simple physical process. Okay, so that is a mixture. Now next one is mixtures are of two types. One is homogeneous mixture, another is heterogeneous mixture. Now let us discuss the meaning of these two mixtures. In that, first, homogeneous mixture. So homogeneous mixture, when we mix the two components and they form a uniform substance. Okay, so for example, if we add sugar in water, then we get a one phase. So that mixture is called as homogeneous mixture. Then what is heterogeneous mixture? In this mixture, mixing of the component is non-uniform. For example, if we add kerosene, petrol in water, then we get different phases. That is heterogeneous mixture. Now let us discuss the solutions. What is the meaning of solution and what is the component? So solution is a homogeneous mixture of two or more components, and we'll explain it with the help of solute and solvent. So when we add two or more components, then we get a solution. So what is solvent? The component present in the solution which is in large quantity, in which the another component get dissolved, and the dissolved substance or component which is present in small quantity which get dissolved in the large quantity solvent, that is called as solute. So for example, when we prepare a solution of sugar in water, sugar which is taken in small quantity, it is solute, and water is taken in large quantity, that is solvent. Sugar get dissolved in water. Then binary solution, solution containing two components. Bi means two, that solution is called as binary solutions. Then we will discuss the next part. That is the types of solutions. So there are different types of solution on the basis of physical states of that solute and solvent. So all are familiar with three physical states: solid, liquid and gases. So if we make a different combination, we get 9 types of solutions. First, when your solute is in solid state and solvent in liquid state. So just now we will discuss one example when we prepare a solution of sugar in water. Here sugar in solid state and water in liquid state. So it is a first type, that is solid liquid solution. Similarly, we can prepare a solution of when different minerals are dissolved in water, which is observed in sea water. Then next one is if we add benzoic acid in benzene. These two are organic in nature. Here benzoic acid is in solid state, benzene in liquid state. The next one is solid type. Solute is in solid state, solvent is also in solid state. So all are familiar with alloys, brass, bronze, in which all metals are in solid state. Okay, then third type is when solute is in solid state and solvent in gaseous state. So iodine in air. Iodine in solid state when kept in one dish, and when that iodine get evaporate, it get dissolved in atmosphere. So that air is in large quantity, so it is a third type. Okay, then fourth type is when solute and solvent both are in liquid state. Example is gasoline. All are familiar with ethanol in water solution. When we add ethanol in water, so we make a homogeneous mixture. Then when solute is in liquid state, solvent in solid state, amalgam of mercury with metal. For example, sodium amalgam in water. So we prepare an amalgam of sodium with mercury. So that is a fifth type. Then sixth type is when when your solute is in liquid state and solvent in gaseous state. So if we take nitrogen gas and if we add liquid chloroform, then we prepare this type of solution. Then seventh type is when your solute is in gaseous state and solvent in liquid state. For example, when we dissolve carbon dioxide in water under high pressure, different beverages such as Coca-Cola, Pepsi, these are different aerated drinks can be prepared by different methods by using this type of solutions. So don't write the names of brands, but write only example. Okay, so carbon dioxide is dissolved in water, oxygen is dissolved in water. So this is a 7 type. Name 8 type is when solute is in gaseous state and solvent is in solid state. So all are familiar with the reducing agent. When we use reduction of your alkene into alkene, we use this catalyst, hydrogen on palladium. So palladium is in solid state, that gaseous hydrogen is deposited over that palladium, and when you pass your ethene, it gets converted to ethane. So this is a 8 type. Then when your solute and solvent both are in gaseous state, so air is the best example. In that oxygen, argon, nitrogen and different gases are present. So this is about the types of solution. Now next one is the capacity of solution to dissolve solute. So depending upon the amount of solute dissolved in a solvent, we have the following types of solutions. Let us discuss one by one. First one is unsaturated solution. A solution in which more solute can be dissolved without raising temperature. So if temperature does not rises, then we can prepare a unsaturated solution. Okay. Then second one is saturated solution. So what is saturated solution? A solution in which no solute can be dissolved further at a given temperature. So if we kept the temperature at constant level, and if on adding your solute and if you stir the solution, if your solute cannot be dissolved, then that solution is called as saturated, because further solute cannot be dissolved. And third type is super saturated. So what is super saturated? A solution which contains more solute than what would be necessary to saturate it at a given temperature. Means we have to take that saturated solution, and if we add few more solute in that same solution which cannot be further dissolved, okay, and the capacity is full, that is when solution become saturated, that is called a super saturated solution. And we achieve a equilibrium between your solute and solvent. That condition is called as equilibrium condition, and your solution is called as super saturated. Such solutions are unstable and we get a precipitate, means your solute is in remain solid state in your solution. Okay, so this is about the super saturated solution. Then next one is solubility. Solubility is a maximum amount of substance that will dissolve in a given amount of solvent at a specific temperature. Then there are three direct factors that affect on your solubility. First is nature of your solute and solvent. So substances having similar type of intermolecular forces are likely to be soluble to one another. Okay, so it is one rule is there, like dissolving like. Generally polar solute dissolve in polar solvent. This is because solute solute, solvent solute and solvent solvent interactions are of similar type. For example, if we add NaCl in water, here NaCl is a solute and water is a solvent, there is a strong ion dipole interaction of Na plus and Cl minus ion with your water molecule, and we observe there is a hydrogen bonding between water molecule, as well as there is a ion-ion attraction between Na plus and Cl minus ion, which are comparable. So this is the first factor. But if we consider non-polar organic solvent like cholesterol dissolve in non-polar solvent such as benzene. Okay, so you have to remember one key or hint, like, dissolve, like. Okay, then all of you understood one more example, sugar dissolve in water. So the dissolution of that sugar in water is due to intermolecular hydrogen bonding between sugar molecule and water molecule. Then can you tell me why naphthalene dissolve in benzene but not in water? So write down your answer in comment box and send it to me. Now next factor that we have to discuss is the temperature. So what is the effect of temperature on solubility? It is depends on enthalpy of solution. So that you already learned in chemical thermodynamics. So what is the enthalpy of solution? It is the amount of energy required to raise the temperature of dissolving that substance in definite quantity of your solvent by at some same temperature and keeping the pressure remains constant. Okay, that is enthalpy of solution. So many solids, for example KCl, dissolve in water. So here there is a decrease in temperature and heat is absorbed by that KCl, so it is a endothermic process. When temperature increase by adding of heat to that system, the solubility of that system substances increases according to Le-Chatelier principle. For that purpose, you have to follow chemical equilibrium topic from 11th standard. So what is Le-Chatelier principle? You can write me in our comment box. Then addition of heat causes a stress to that saturated solution, and this stress favors endothermic reaction. On the other hand, when the substance dissolves in water by an exothermic process, in this exothermic process it is given out, temperature falls. Okay, sorry, temperature rises. The substance such as calcium chloride CaCl2, lithium sulfate dissolve in water by release of heat. That means it is a exothermic process. Then temperature affects the solubility of both solids and gases, but pressure will affect only on the solubility of gases. Then third factor is pressure. So there is no effect of pressure on your solubility of solid as well as liquids, because they cannot be compressed. However, the pressure greatly affect on the solubility of gases in liquid state. Means when you are solute in gas state and solvent in liquid state. Then if we check the effect, solubility of gas or gases increases with increase in the pressure. Okay, and to study this effect of gases, solubility of that gas in liquid and the relation of that solubility with pressure, You have to learn one law, and that law is called as Henry's law. Okay. Now next is so here you have to revise this point. Like dissolve in like. Okay. Non-polar molecules like naphthalene and anthracene dissolve in solvent like benzene and carbon tetrachloride, which is also non-polar in nature. Okay. Let us discuss the next one, that is solubility. Solubility is maximum amount of a substance that will dissolve in a given amount of salt at a specific temperature. So this is about the solubility. Then there are three factors which affect on the solubility. First one is nature of solute and solvent. Second is temperature. Third one is pressure. Temperature affects the solubility of both solids and gases, but pressure only affects the solubility of gases. So let us discuss the first factor, that is nature of solute and solvent. Generally, all are familiar with the rule: compounds with similar chemical characters means their nature is same. So one rule is there, like dissolve like, are more readily dissolve or soluble in each other. For example, all are familiar with the sugar solution, then common salt solution. Here your sugar and your NaCl and water both are in same nature, so they are polar compounds. So polar, by that rule is mentioned, like dissolve like. So let us consider the example. Polar molecules like sugar, sodium chloride dissolve in water, and both are same type of nature, that is polar type. Non-polar, for example naphthalene, anthracene dissolve in compound like benzene or carbon tetrachloride. Here all these are non-polar in nature. So like dissolve like, this is the key. Then nature of solute and solvent. So substances having similar intermolecular forces are likely to be soluble in each other. Generally, polar solute dissolve in polar solvent because in these there are three types of interactions: solute-solute, solute-solvent, and solute-solvent, the second one, and third one is solvent-solvent type of interactions, and all these are of similar in magnitude. For example, NaCl dissolve in water. Here NaCl is in solid state, water is in liquid state. NaCl is a solute, water is a solvent. If you observe this solution, there is a strong ion dipole interaction of cation Na plus and anion Cl minus with water molecule. As well as if you observe, in case of water there is a hydrogen bonding, and if you observe Na plus and Cl minus ion, there is a ion-ion attraction, and all these are comparable. Then next one is the effect of temperature on the solubility. So many solids dissolve in liquid water. The solubility increases with increasing temperature. This is the common rule. So we can write the relation between solubility and temperature. They are directly proportional. So increase in kinetic energy that comes with higher temperature. Means if we increase the temperature, kinetic energy of that system increases, and it allows the solvent molecule to more effectively break apart the solid molecule, and that are held together by intermolecular attraction. So that we already discussed solute solvent, solvent solvent, and solute solute type of interaction. Due to increase in temperature, that interaction undergo broken. So let us discuss the diagram, that is the graph of your solute in gram and temperature in Celsius. So that is also known as solubility curve. So for example, let us discuss the solubility of NaCl, NaBr and KCl changes slightly with temperature. So here we observe the NaCl, then this is KCl, and NaBr is not mentioned here, but their solubility increases slightly with increase in temperature. While solubility of KNO3, this is solubility of KNO3, NaNO3 and KBr, it is not mentioned here in your graph, increases appreciably with increase in temperature. While to consider the SO2, solubility of SO2 decreases with increase of temperature. But if you observe solubility of, so here we have to mention, instead of here but right here SO2, yes. Solubility of SO2 decreases with increase of temperature, and the solubility of gases in water usually decreases with increase of temperature. So just now we discuss solubility. If you observe the solubility of HCl and ammonia, it also decreases with increase of temperature. Okay. When gases are dissolved in water, the gas molecule in liquid phase are condensed. So for example, your ammonia, SO2, okay, these are in gas state, they get condensed, and the condensation is an exothermic process. The solubility of gases in water must decreases as temperature rises. Okay. And next one is the effect of temperature pressure. So pressure has no effect on the solubility of liquids and solids, as solids and liquids are incompressible, while there is effect of pressure on the solubility of gas because we can compress the gas. So if we increase the pressure, solubility of that gas increases. Then there is a quantitative relationship between your solubility of gas with pressure, and it was studied by a scientist Henry, and one law is put forth, and that is called as Henry's law. Thank you for watching my channel. You can like, subscribe Mukesh KHARGE on YouTube. Thank you very much.